Welcome. In this video, we are going to study work and energy, class 9th NCERT, chapter 11. So let's revise it. Like work, what is work? There is a different way we use the term work, day-to-day life. So we use work in a day-to-day life in a different term, in a different way, and the way we use in science has a different, so there is a difference between the way we use the word work in science and the way we use the work in our daily to daily life. Maybe I'm working in kitchen, I'm working in floor, maybe uh, the work we use, the word we are using in daily life, it is different from what we understand it in scientific way. So, what is the scientific concept of the work? Push a pebble lying on the surface. The pebble moves through a distance. You exerted a force on a pebble and the pebble got displaced. This situation is called work is done. Suppose it is a pebble and you push the pebble and it displaces to here, and that displacement happen due to the force applied in this direction, and this displacement happen, and this is supposed to be a work is done in this case. Two conditions needed to satisfy the work. First, force should act on the object, and second, the object must displace. It is very important, there must be a displacement. If the object is not displaced, that means the condition not satisfied. If the condition not satisfied, the work cannot be done. If any of the above condition does not exist, work is not done. In this way, we view the work in science. This is the work in science. So suppose I'm working in my college, or if I'm working in my uh, like computer or in office, that it's a different way we are using the word work. I'm working in a project, this is a different sense we use in daily life. But in science, work is when you apply the force on an object and the object displaces. Two things happens: you apply the force and object displaces, and this is called work is done. So how we can represent is work is like force into displacement. There must be force and displacement in it, and force into displacement is work done. Work done by a constant force. We defined a work done equal to the product of force and displacement, W equal to F into S. And thus the work done by a force acting on an object is equal to the magnitude of the force applied by the distance moved in the direction of the force. So this is magnitude of the force will be F, and into the distance moved D. So work done will be force into the distance it displaces. The unit of the work is a Newton meter. F is definitely a Newton, and D is in distance in meter. So definitely its unit will be Newton meter. Thus 1 joule amount of work done on the object when the 1 Newton of force displaces it by 1 meter along the line of action. So it's now force is in Newton. So this is N means 1 Newton, and D is a distance in meter, which is a 1 here. So this work is it has a joule unit. So 1 joule works happens when 1 Newton of force is applied on an object. This is force of 1 Newton applied on an object, and it displaces by 1 meter. It displaces a 1 meter, and this is called 1 joule of work is done in it. This is how we can understand this. And work done by a force can be either positive or negative. See, if the distance is like, if it goes this way it is positive, then it goes the opposite way it is negative, and similarly force can be negative. So so the work done can be positive and negative both way. And there is a numerical. A porter lifts a luggage of 15 kg from the ground and put it on the head of above 1.5 meters above the ground. Calculate the work done on the luggage. Work done simply will be like force into displacement. Force, we have only the porter lifts luggage of this kg. So F is again, we have only distance. The displacement of the luggage happen to 1.5 meter. So we have a 1.5 meter as a displacement. And force is, we don't have a force Newton here, so we have only, we have given this which is a weight. So force is also mg, mass into gravity. So this is also the force which we call it weight. We just discussed this in a gravitation chapter. So mg, m mass is 15 kg, and g is how much? G will be 9.8. So this is how, by multiplying all this value by, by making the unit same, we can find uh, how much was work it done. This is what it has derived, 15 kg, and he has taken gravity as a 10, and this was the displacement when the porter lifted luggage from ground to his shoulder. So the work done is calculated at 225 joule, 225 joule. Now discuss about the energy. What is energy? Also, uh, like work, we use energy in many ways, and but we have a different meaning scientifically about the meaning about the energy. Life is impossible without energy. The demand for energy is ever increasing. Where we do where where do we get energy from? The sun is the biggest natural source of energy to us. Many of our energy sources are derived from sun. Sun is a major source of energy for us. Sun gives energy, and we also get energy from nuclei of the atom, and interior of the earth, and tides. These are some natural forms of energy. And sun gives energy through photosynthesis. The plant make food, and humans eat that food, and in form of this. uh, Energy purchases by an object is thus measured in terms of capacity of doing work. What is energy? Energy is just a capacity of doing work. This unit is therefore it's same as the joule. Forms of energy. What are its forms? There are multiple forms. One is mechanical energy. Mechanical energy includes potential energy and kinetic energy. This is mechanical energy. We have heat energy, chemical energy, electrical energy, and light energy. What are James Prescott Joule was an outstanding British physicist, research in electricity and thermodynamics. Also formulated the laws of heating effect of electric current. Laws of conservation of energy was also like experimentally verified by him, and the unit of energy and work is called joule, named after him. So what is a kinetic energy? Let's discuss this. Kinetic energy, the kinetic energy is energy possesses by an object due to its motion. If the motion is happening in any object, then the energy it possesses is called kinetic energy. It is formed in the kinetic energy. The kinetic energy of an object increases with its speed. The speed is increasing, the kinetic energy is increasing. If the motion is increasing, kinetic energy is increasing, and vice versa. How much energy possesses by a moving object by virtue of its motion? By definition, we say the kinetic energy of an moving body moving with a certain velocity is equal to the work done to acquire that velocity. So, what is kinetic energy? Kinetic energy will be equal to the work done on the object to make it moving. Suppose this was of an object which is at rest. I give in a force. I give in a force, and it is displacing by 1 meter and 1 meter, and this it displacing and speeds we are giving the constant force in it. It is displacing by 1 meter per second, and it goes here. So the work we are doing, the work we do, F equal to W, this is a work done, will be its kinetic energy. This is what it's saying. The kinetic energy of a moving body with a certain velocity is equal to the work done on it to make it acquire the velocity. So this is what a kinetic energy is. And it has a formula which we just derived. It is K equal to mv square. This is mass, m means mass, and v is velocity. And now discuss the potential energy. And potential energy and kinetic energy, these are almost like interchangeable. The energy get stored due to the work done on an object. So it is similar. Kinetic energy was when the work is done by to move an object at a constant speed. This is the kinetic energy. And if the work has been done, and the stored work on an object is a potential energy. The energy gets stored due to the work done on an object. The energy transferred on an object is stored as a potential energy. Okay, you transfer energy when you stretch a rubber band, and the energy transfer to the band is a potential energy. Suppose this is a rubber band and you stretch is this long, and you did a work done. Work has been done by stretching this rubber band, and now it has a potential energy. Potential means like it want to compress again. So this energy is a potential energy. Potential energy possessed by an object is energy present by virtue of its position and configuration. This is most important. By virtue of its position, see its position is like elongated now. Now its position, due to its position, now we take we did work to change his position, and in this position he wants to again compress. So it has a potential. The force by it is applying to get its original state, it is potential energy, because this is the force. Suppose 10 Newton force was applied to stretch the whole rubber into this, and 10 Newton force will be a restoring force. It want to restore into its original position, so its potential energy will be the 10 Newton, which is equal to the force that we have applied when we were stretching the rubber band. Example of the bow arrow. An arrow or a stretched string of a bow is it's like potential. It has a potential. So the energy that we are requiring to getting it back will be equal to the potential energy, and it wants with same force to go in this direction, in opposite direction. Now discuss about the potential energy of an object height. Gravitational potential energy of an object at a point above the ground is defined as the work done in raising it from the ground to the point against the gravity. So suppose it is ground and we lift it, and the work that we done, the force and displacement we applied is its potential energy. So suppose we applied 10 newton of force for like 1 meter, lifting up 1 meter, and that energy will be the potential energy. The work done in rising it, the work is done the work done in raising an object from the ground is potential energy under the gravity. This is what the gravitation potential energy is. Work done will be the force into displacement, mgh. Force is mg, mass into gravity. And this is why since the work done on an object is equal to the mgh, the energy equal to the mgh unit is gained by the object. This is called potential energy. So potential energy is mgh. It is simply the work is done. How much work is done? The work is done to lift the object of the ground above the surface of the earth is will be the force into displacement that we just discussed in the just in a work session. And definitely the force is mass into g. This is a weight that we discuss in gravitation chapter. F equal to mg. This is a force on an object which is applied uh, by the earth due to its gravitation. And gravity depends on the difference in vertical heights. It only depends on difference in vertical heights to initial and final position. So initial and final position is important of an object, not the path along which the object is moved. It's not depending on the path, it is depending on the distance from the minimal from the initial and final position. So this is will be the minimum distance, not the actual distance. It might have actual distance might be more than the minimum distance. In both situations the work done will be mgh. So in both cases object is lifted up this way, and in this way it is well lifted straight. In both way, as we are calculating the initial and final position, simply vertical position only, not horizontal positions. So the work done will be same as the height is same. Are the various energy forms interconvertible? Yes, there are multiple forms of energy we will study, and they are interconvertible. We find in nature a number of instances of conversion of energy from one form to another form. And what is the law of conversion? According to this law, uh, the energy can only be converted from one form to another form. It can neither be created nor be destroyed. It can neither be created nor be destroyed. So it can only convert its energy from one form to another form. The total energy before and after the transformation remains the same. The law of conservation energy is valid in all situations for all kind of transformation. So the potential energy and kinetic energy is always a constant. If some object is moving at the velocity, this potential energy is there. And this can be explained with example like some ball we like lift is lift up is thrown from the ground into the sky. Its kinetic energy increases and potential energy will be zero, and slowly it will slow down, and the potential energy will be kinetic energy will decrease and the potential energy will be increased. At the top here the potential energy is a max and kinetic energy will be minimum, almost zero. Then it will fall down under free fall under gravity. Its potential energy again decreases and its kinetic energy will again increases, and its kinetic energy at here will be max and potential energy will be minimum. So kinetic energy is increasing, then potential energy is decreasing. This is vice versa is happening, and these are always the sum of these are the sum of these energy will be all constant always. So mgh potential and half mv square will be constant. The sum of the kinetic and potential energy of an object it's a total mechanical energy. So mechanical energy will be same in every object, although its kinetic energy and only these energy kinetic and potential will changes. Rate of doing work, now discuss this. The power is a power measures the speed of the work. The power is defined as rate of doing work. Rate of doing work means if work is done in minimum time, the power is more. If it takes lot of time, the power is less. So the rate of transfer of energy the is a power. Power can be derived work into time. How much work is done and how much time was taken. So the power is like proportional to inversely proportional to the time. Is more time is taken to doing work, so less power was used, and if less time is taken, the more power is needed. It's defined as rate of doing work. How long at what rate the work is doing. It is a fast or slow. The unit of power is a watt, and kilowatt, kilo means 1000 and 1000 will be 1000 watts. 1 kilowatt has 1000 watts, and watt is also expressed joule per second. Power is a watt, joule per second. This is a joule per second. Work has a joule unit, and time has a second. So it goes up, second goes up here to s minus 1. This is a joule per second here. Then commercial unit of energy. Uh, the unit joule is too small and hence inconvenient to express the large quantities of energy. So we need a bigger unit, so that we use a kilowatt hour. Kilowatt hour. So what is a kilowatt hour? Kilowatt and hour. So 1 hour has that much second, and 1 kilowatt has 1 kilo has 100 watts, 1000 watts. Sorry. So 1 kilo, by multiplying this, 1 kilowatt has uh, 3.6 into 10 to the power 6 joule of energy. 3.6 lakh joules, 1 kilowatt. For example, electrical energy we use during a month is expressed in terms of unit. Here a unit means 1 kilowatt hour. We have an electric bill like 50 units was used, 100 units was used in a month in a domestic housing. So this unit is a kilowatt hour, and 1 kilowatt hour is 3.6 lakh joules. Okay, we have finished the chapter. Let's revise it quickly. The work done on an object is defined as the magnitude of the force multiplied by the distance moved by an object in the direction of applied force. The unit of the work is a joule, and the joule will be force into displacement. Newton into meter. Newton meter will be its unit. The work done on an object by a force will be zero if the displacement will be zero. If see if, if d will be zero, so f into 0 will be 0. Though the displacement should be there should be a displacement. If displacement is 0, then work done is 0. Suppose the force is applied in a circular way and the initial and final position of an object remains the same, and in this case displacement is 0, then there is no work done in this case, because it will make the whole equation 0. Kinetic energy is half mv square. This is what we studied just before. And the gravitational potential energy of an object of a mass m is mgh. M raises through the height, mass is raised through the height h. So object of a mass m, gravitational potential energy of an object of mass m raised through the height h from the surface of the earth is given by mgh. According to law of conservation of energy, energy can only be transformed from one form to another form. It can neither be created nor be destroyed, and the total energy before and after the transformation always remains constant. The energy exists in nature in several forms such as kinetic, potential, heat energy, chemical energy. The sum of the potential and kinetic energies of an object is called its mechanical energy, and it's remained constant. And the power is defined as rate of doing work. SI unit is watt, and the energy used in 1 hour at the rate of 1 kilowatt hour is called 1 kilowatt hour. So sorry, energy used in 1 hour at the rate of 1 kilowatt is called 1 kilowatt hour. And J is a unit of energy into unit of work. 100 watt will be 100 joule per second. The energy which is going 100 joule per second. And here ends the chapter. Thanks for watching.